Mains electricity. Now you need to know about two types of current, direct current and alternating current. Now direct current is the sort that comes out of cells and batteries because they push current in one direction only. So this is direct current, DC. The definition, which you need to learn, is current that always passes in the same direction. And then there's alternating current, or AC, and this is one that's always changing direction, and this is supplied by mains electricity coming out of power stations. It flows one way and then it reverses, and the frequency of reversal is about 50 cycles per second for mains electricity in the UK, or 50 Hertz if you remember frequency from Unit 1. So you can show DC and AC on oscilloscope traces. We talked about oscilloscopes in Unit 1. So on the left here we've got oscilloscope trace for DC current. Now for DC current it's shown as a straight line because it doesn't reverse. And the PD can be read off the scale. So here, for the red line, the PD is 10 volts. But if PD is reversed, then the line is shown below that line. AC current. So for AC, the oscilloscope trace is shown as a fluctuating line, and the peak voltage on this trace is about 14 volts, although the average voltage is lower. In the UK, the average voltage is 230 volts. Now if there's an increase in PD, it makes the waves taller. And if there's an increase in frequency, it makes them shorter from peak to peak. Now the time taken for one cycle is called the period. And if you need to work out the number of cycles per second, then it's 1 divided by the period. Now remember, one complete cycle is from peak to peak. Now electrical cable comes as two types. You can have 2-core cable or 3-core cable. Now in both cases they contain copper wires, which are conductors, and the wires are insulated with plastic or rubber casing. Thicker wires can carry a higher current, and the current rating of the appliance determines the thickness of the wire to be used. 2-core cables are used for appliances with plastic casings. They don't have an earth wire, which we'll come on to in a minute. Now you need to know the structure of a 3-pin plug. So you need to know which wire goes where, neutral to the left, earth to the top, and live to the right. You need to know why the materials used are as they are. Why are the pins made of brass? Because it's a good conductor, and it's harder than copper, so it means it can be forced or shoved into sockets, and it doesn't oxidize. And the case is made of plastic or rubber, which is an insulator, so it stops the pins and the wires from coming into contact with each other.